Okay, so the last kind of ionic compound we're going to talk about are acids. Okay, and they are kind of a subgroup of themselves. And the way you recognize an acid is that H1 plus is always dropped and swapped, and it's always written first. Okay, not elsewhere. Sometimes you'll see things like sodium, hydrogen, carbonate. That hydrogen, this is not an acid. What you're looking for is to be written absolutely first. Okay, so there's two kinds of acids, oxy-acids and non-oxy-acids. What this means is they have oxygen and they have no oxygen. That's the difference between them. And acids are formed when the cation, the first thing written, is H1 plus, dropped and swapped with an anion, so they are ionic. Acids always start with an H. That's how you recognize them. Okay, they're not called hydrogen something. So non-oxy-acids, the ones that don't have the oxygen in them, if the acid is binary, meaning it's got no oxygens, then the name is hydro something ic acid. Okay, and so you've heard these before. Hydrochloric acid most likely. So HCl, notice there is no oxygen. It's just hydro, then chlor, the root of it, ic acid. Okay, if you have H2S, the reason there's a 2 here is because H is 1 plus and sulfur is negative 2. When you drop and swap those, this is what you end up with. The way you name it, though, is you take the name for S, sulfur. You don't use a root. If you called it hydrosulfuric acid, I'd let it go. But it sounds weird. So it's hydrosulfuric acid. Again, notice, no oxygen. Okay, HI, again, you take the root name for the I, iodine becomes iod, and it's hydroiodic acid. Okay, oxyacids have oxygen, at least one. Okay, and then the anion comes from the chart that you guys have of the polyatomic ions. So they do not have the word hydro in the name at all. That's how you recognize them. The way it works is if the anion off the chart ends in ATE, then the acid becomes, whatever the root of that is, ic acid. Notice, not hydro, just ic acid. Okay? If it ends in ITE, and again, off the chart, then it becomes the anion root, whatever it is, and it ends in OUS, acid. And that's how you tell the difference between them. But you need the chart to figure out. Okay, so for example, HNO3 comes from nitrate, so it becomes nitric acid. The reason it's got an H in the front is if you drop and swap that, they're 1 to 1. Okay, HNO2 is done the same way. It comes from nitrite, so it's nitrous acid, but it's done the same way, the formula. It's just it's got 1 less oxygen in it. Okay, so these are oxyacids. They have oxygen in them. There is not the word hydro. Okay, so examples of some acids. This comes from chlorate. If it's on the chart, you look at the ending name, drop and swap the charges, and it's called chloric acid. Don't get confused with hydrochloric acid. Hydrochloric acid is HCl. It doesn't have an oxygen in it. Okay, oh, there you go. Hydrogen chloride comes from hydrochloric acid. So there's a difference between this one and that one. And the only way you can tell from the name is the one that doesn't have oxygen does have the word hydro. H2SO3 comes from sulfite. In the 2, if you drop and swap, you end up with 2 H's. It's called sulfurous acid. H2S comes from sulfide. You drop and swap. It's hydrosulfuric acid. It has hydro because there are no oxygens. Okay, so the way you write the formula, all you need to do is identify whatever the anion is. So what you want to look for is the word hydro or not, and then you're going to drop and swap with the same thing every time. Okay, so nitrous acid I recognize comes from nitrite, so I'm going to drop and swap with that. Okay, so drop and swap, you get HNO2. Hydrofluoric acid, I recognize this, and that tells me, all right, it has to be on the periodic table, so I'm going to drop and swap with those two, HF. Sulfurous acid comes from sulfite, again, drop and swap But notice this one has, sorry, that's got a 2 outside the parentheses, drop and swap. You end up with H2SO3. That 2 came over from the sulfite. Okay, so go ahead, see if you can solve these. Pay attention to how many oxygens they have, or what formula they have, or if they have oxygens at all, based on that. So for example, I'm going to look at this one and I immediately recognize hydro. That means it comes off the periodic table. So when I drop and swap, I get HBr. Carbonic acid does not come off the periodic table. It doesn't have that word hydro. That means it comes from carbonate. When I drop and swap, H2CO3. That's the fizziness in soda. Acetic acid, again, I don't see the word hydro. That means it comes off the chart. Acetate is this. And when I drop and swap, HC2H3O2. Notice I did not combine the H's. I have to keep that acid H on the very front. I can't combine it with those three because those three belong to acetate. This one belongs to the word acid. Okay, so I'm looking at this. I don't see anything. I can clearly tell it comes off the periodic table. That means it's hydrochloric acid. This one is not on the periodic table by itself. It means it comes off the chart. And it's nitrite, which means this is nitrous acid. This one, again, it's not on the periodic table by itself. It comes off the chart. It is phosphate. That becomes phosphoric. If you wanted to call it phosphic, I'd let it go. You should probably stick the word acid in here. I do want to point out one thing. I want you to think about this for a second. Why is there a 3 there? Okay, take a look at your chart and see if you can figure out why there's a 3 there, based on the fact that this is phosphate. Okay, this one, I see that F is on the periodic table. That means I'm going to use the word hydro, F-L-U-O-R-I-C, acid. Make sure you spell it right. Okay, but that's the way acids work. Either they're on the periodic table, in which case you use the word hydro, or they're on the chart and all you do is pay attention to how they end. Okay, so you just have to be really careful with that.